inverse. Okay, so inverse. It is as simple as this. When we're trying to find the inverse, we're going to look at inverse with table, graph, and equation. All right? So first of all, I'm just going to do this. Inverse with the table. So I have my x values. Okay, guys, here we go. We're going fast. We have a lot of ground to cover tonight. So we have our x values and we have our y values. If I ask you to find the inverse of this, the inverse would simply be switching the x, y values. It's as easy as that. How do you like that? Is that cool math? Okay. So you just take your x, y values and you flip them. So your y values become x. What we're doing is switching the domain and the range. That's how you find an inverse. Switch the domain and the range. All right? Let's look at a graph. Well, do I want to take you there? Yeah, let's do this. Let's try this one. So this is a table, obviously. Let's look at a graph. Finding the inverse of a graph. I'm going to use the points. Where should I put them? I'll just put it right here. Just to give you the points of this graph. 0, -8, 1, -4, and 2, 0. Those are the points I'm using on this graph. So when x is 0, y is -8. When x is 1, it's -4. And when x is 2, y is 0. So I have this little graph that looks something like that. Pretty straightforward. Okay, now, because of the principle I just taught you, we already know what's going to happen to graph its inverse, right? What are we going to do? Switch the x, y value. So now, when y is 0, 8 is -8. When y is 1, where are we at? X is -4, right? And when y is 2, x is 0. So I have simply switched the x, y values, and I have something that looks kind of like that. Sorry, I missed the point. Okay, so that is what the inverse looks like. Now I want to show you this principle. When you have, oh my lands, I got to get on here. Okay. The inverse, hopefully you can see those dotted lines. The inverse will always reflect over the line, or is symmetric to, whatever you want to, however you want to think of it. But it will always, the inverse will always reflect over the line x equals y. All right? And that sheet that I handed you at the beginning of class, you're going to have to do that kind of stuff. So you're going to have to show that the inverse reflects, meaning it's just a mirror image over the line x equals y. Okay? Are you okay with graphs? Yes?
Like, what do you mean by x equals y? Like,
this little line right here I just drew is the line x equals y, meaning when x is 1, y is 1. When x is 2, y is 2. And so this inverse will reflect, so if I were to fold my graph on that line, it would just be a mirror image to the real function. Does that help you a little bit?
Yes.
Okay. Good question. You guys keep asking. Ask questions as I fly through. Okay. Now, let's look at an equation. Okay, with an equation, let me give you one here. here we go. Let's try this one. 4x minus 8 equals 12. And I want to find the inverse of this equation. Actually, time out. I need a y. I'm going to say y equals, that's okay, 4x minus 8. Y equals 4x minus 8. The steps to finding the inverse of an equation is number 1, you switch x and y, and 2, you solve for y. It's that simple. Okay, so the first step says switch x and y. So literally, I'm going to put my x equals 4y minus 8. Just switch x and y. Now you solve for y. So 4y equals x plus 8. So I've just added 8 to both sides. Okay? And so we know that y is x plus 8 over 4. That is the inverse. That is the inverse of this original function. Questions on finding inverse? So we have to find, can you not see down there, guys? You can stand up. Just because this is going, you can still ask, talk, it's okay. It'll help the students. Ask questions, okay? Most likely the question you ask will be the question they have, so it's okay to talk. You guys are funny. All right, so you just switch x and y and solve for y. Questions? I'm going to have to shut this thing off for a minute if you don't ask me questions. Okay. Are you okay? All right. So we did table, graph, and equation. And it's as simple as that. Now, usually I would give you time to work on your little worksheet, and I'm not. But it's very easy. Let's look at it really quick. Okay, so the first thing you have to do on this worksheet, if you will look at it, this one that went around. Do you see how we have the function f of x equals x minus 2 cubed plus 3? You're going to do, I call it plug and chug. So our first x value is 0, put a 0 in for x and find out what your y value is. Does that make sense? So just substitute your x value in, find out what y is. So fill out the table, then you'll graph it, and then you'll find the inverse of it. Down here, remember you just take little tiny steps all the way through. So when you find the inverse, you're just going to switch your x and y values. You're switching your domain and your range. And I think it's pretty easy to get through. So I am going to move on just because this is not hard. Okay? And if you have questions for me next week, I will answer them on this sheet. You will not turn this in. This is a binder assignment. And so, but next week I will make sure to ask you, did you understand the inverse sheet? All right? What's that? And you'll say, I am just fine, huh? It's not hard. I want to get on to logarithms and exponents because that's the meat. That's what we really need to know. Okay, let's see here. I'm looking to see what I want to do with you. This is what I want. By the way, how far do we have to go tonight? Okay. Next week we start solving. I think I'm covering a couple lessons here. Okay.
Next week is
Get our take-home test next week.
yeah. And then the test is like during the finals.
Okay.
I'm not gonna know about it.
I'm just going to start with it.
When the binder comes out, I'm just gonna be like, what? Don't have anything.
All right.